So in this video we'll be discussing price elasticity of demand. So first of all we'll go over its definition, then we'll discuss its formula, and then we'll go over the ranges of PED. So let's start off with the definition. So price elasticity of demand, or PED for short, is the responsiveness of quantity demanded to a change in price. This won't really make sense right now, but when we look at the formula that will make much more sense. So this is the second part, the formula. So the formula for PED is percentage change in QD over percentage change in price. So let's look at this definition here. So price elasticity demand is the responsiveness of quantity demanded to a change in price. So basically, how much quantity, how much of the demanded quantity changes if there is a percentage change in price. So let's say if there is a 1% change in price and there is a 5% change in QD, that basically means the value of PED is 5, right? Because this is a formula for PED, and this is exactly what we can use to explain this definition, which is how much quantity demanded changes to a change in price. And let's say if you want to calculate the percentage change in be it whether QD or price, you can just use the formula new minus old divided by old into 100. So this is what you have to use in order to calculate the percentage changes, and then you can just divide the percentage change in QD with the percentage change in price to calculate your value. Let's have a look at the ranges of PED. So the first range that we have is perfectly inelastic. So over here the value of PED is equal to 0. And what does that mean in terms of the formula? So let's have a look. So this basically means that since the value of PED is 0, even if the price goes up, or let's say even if it goes down, there is no change in QD. QD remains constant because we know that the x-axis represents quantity, the y-axis represents price, and so whenever there are changes, let's say over here, even over here, there are changes in price, price is increasing, or even if the price is decreasing, the quantity remains the same, and so the value of PED over here is 0. Now moving on, this is the second one, so it's relatively inelastic / inelastic PED. So over here the value of PED is less than 1. In terms of what that means in the formula, so let's say if the price goes up by 10%, and we know that whenever price goes up, QD goes down according to the law of demand. So when price goes up by 10%, and let's say QD falls by less than 10%, which means it falls less than proportionately as compared to the price, and so it's gonna fall, let's say, by 5% or maybe 7%. So any percent value below 10%, and it will be counted as inelastic, and the value of PED will be less than 1 until obviously we reach 10. That's going to give us a value of 1 only, because 10 divided by 10 is 1, and so any value before that it's going to give us a value of PED which is less than 1. Then the next one is relatively elastic / elastic PED. So over here the value of PED is greater than 1. Okay, so let's have a look at the formula now. What does it mean in terms of the formula? And there's one difference in the diagram. So over here the curve is a bit steeper as compared to this one. This one is a bit more laid back. And so this is how we explain it in terms of the diagram. And in terms of the formula, let's have a look. So over here, let's say if the percentage change in QD is 10% and the percentage change in price is, let's say, 5%, then over here the percentage change in QD is actually greater than the percentage change in price, which is why it will give us a value greater than 1, because we know 10 divided by 10 is 1, and so any percentage change in QD over here, sorry, it's 5 over here. So I'm going to just change this value real quick. So let's say if it's 10 over here again. So what's going to happen here is that if we have 10 over here, 10%, so 10 divided by 10 is 1. So if the percentage change in QD is greater than 10, which basically means it's going to give us a value greater than 1, and so it's going to be an elastic PED. Now let's have a look at the next one. Over here the demand is unitary elastic, and so what's going to happen is that the value of PD will be equal to 1. So we saw how if let's say the percentage in price was 10 and the percentage in QD was greater than 10, right? If the percentage in QD was greater than 10, let's say 11, 12%, 13%, or and so on, then in that case the degree responsiveness of QD is relatively higher, right? And so it's going to give us a value of 1, sorry, greater than 1, in terms of relatively elastic or elastic PD. Now in the case of unitary elastic, the proportional changes are equal, and so let's say if there is a percentage change in price of 10%, price goes up by 10%, then QD will fall by exactly 10%. If it was to fall, let's say below 10%, that would count as inelastic, as you saw over here. If it was to fall by more than 10%, as you have over here, then it would count within the range of elastic PD. And since it's exactly 10%, then 10 divided by 10 is equals to 1, and that gives us a value of 1. And the graph is this sort of a rectangular hyperbola. And I think that's pretty much it from this one. Then the next one is perfectly elastic PD, where the value of PD is infinity. So let's say if there is a change in price, maybe 10% again, so 10% increase in price, then in that case the value of QD will just go down to 0, right? We saw how in the first case over here the percentage change in QD was 0. Over here the percentage change in QD is infinite, and so because of that, the demand, obviously there is no demand at any other price apart from this price. So let's say if this was a price of 10, then people are willing to buy every quantity possible of this good. But if the price was to increase to 11 or any other value above that, or decrease to 9 or any other value below that, then people wouldn't buy even a single unit of that good. So that's pretty much it from this video.